Can you hear me anyway? Can you? Okay. If you ever heard my name, chances are that's because I wrote a book called Metaprogramming Ruby. That's my claim to fame in the Ruby community, that and nothing else, because I don't work with Ruby. I'm not part of any cool startup. I don't have any cool new technology to show. I don't even make money with Ruby. Actually, nobody wants to pay me money to write Ruby code. I do that at night, all alone, and I keep the code for myself, basically. And so you might wonder why the heck I take part in a Ruby conference. In fact, I live as an agile coach. I mainly coach big corporations. I babysit managers. I coach people who've been exposed to brain-damaging languages such as COBOL. And still, I do more Ruby conferences than agile conferences. And it doesn't make much sense. It's a money sink. I wonder myself why. And the reason why, the answer I gave to myself is that I like Ruby and the Ruby community for the same reason why I like Agile. Some people say that the Ruby community doesn't get Agile. Some other people say, oh no, they are the cutting edge of Agile. Some other people say they are post-Agile. I wouldn't know. I wouldn't know. I do know that they have one thing in common, and I'm going to let you hanging for about half an hour because I'm taking this from quite a distance, and I'm going to start in 1968. I like this thing with the speaker asking questions and everybody raising their hands. So, how many people in this room were alive in 1968? Okay. Okay, a few. So, I'm 69, I'm cheating. Seriously, 4 people? Okay, no, it's more like 6, okay. Okay. How many people in this room are alive now? Oh, well, look at all those people. In 1968, NATO, of all organizations, organized a conference on software, and the best software minds of their time took part in it, and they came up with a novel concept, a new notion that software was in crisis. They said for the first time that software projects always came in late and over budget, and the quality overall sucked. And even when finally they managed to deliver late over budget after hammering out all the bugs, they usually didn't do what they were intended to. So it was a crisis situation. That's what they said. They called this the software crisis. But they didn't linger on the problem. They also proposed a solution. They said, what we need to solve this issue is a new discipline. And they called it software engineering, which was brand new. Because up to then, software hadn't been that important, really. Hardware was important. Hardware was serious. Software, okay, stuff for low-level technical people, maybe an afterthought. But they said, no, software is important. It's hard, and we have to treat software the same way we treat building bridges or hardware. And how did it go? Well, the software crisis stayed on throughout the 60s, and throughout the 70s, people were talking about it big time. And at the beginning of the 80s, they were still talking about the software crisis. And then they stopped talking about it because, quoting from Wikipedia, I love this, you cannot say you are in a crisis for 20 years. It's ridiculous. At one point, it's not a crisis, it's the status quo. Okay? This is what we have to live with. And sure enough, latest data I found from the Chaos report from the Stansted Institute, 2009, 1/4 of software projects fail, meaning that they fail miserably. They never deliver anything of value. If you take into account the projects that deliver late over budget, then it's more like 75%. 74, 75. So you might wonder what have we done for 50 years? Because we did change the world with software, and still we don't know how to build it. Like, we try, and sometimes, once in 4, we succeed. And that's enough to change the world, apparently. We still suck. In particular, software engineering, they tried hard. They tried to address at least 3 big sources of problems. I'm going through them during the next, 20 minutes. First source of problems is the fact that software is internally complicated. When I say internally, I mean show your source code to somebody, to a layman, and it's amazingly complicated, right? A normal person, if faced with the complexity of the source code of a mid-sized system, they would go like, it's just too complex. How can you do that? In fact, apparently we don't. We get it wrong all the time. And some people said, if we can remove source code, we can remove the problem. Which, it's not that crazy, because if you look at the history of software development, it's the history of abstraction, right? We started from the machine, from the lowest possible level. Then we introduced assembly language, which is slightly more human, mnemonics. And then we went up to more advanced abstract languages, Fortran, C. And then object-oriented programming, there must be something else. Some people said, during the last, 30 years, this something else is probably something that doesn't look like source code anymore. And if you don't have source code, you don't need programmers. You can fire the damn pricks. You can fire all programmers. How beautiful does it sound? This is, you laugh, this is coming up again and again and again. So this is a small experiment. I Googled for the sentence without programmers. And I also searched my memory, my own experience. In 2004, thanks to this technology, I obfuscated it, we'll be comfortable living in a world of computing without programmers. Without. What is this? Any guesses? It's not UML, but that's Okay. Oh, dudes. Okay. If you want to climb on stage, you are spoiling my talk, okay? This one is particularly service-oriented architecture. You don't have to write code, you just assemble services. Serious. This one was an expert. They took him very seriously. Some people still do. This one, from an earlier age, this is long. These things are designed to make the computer solve a given problem without the programmer. Any guesses? Punch cards. Serious. In the 90s, man, you got your history all wrong. No, it's 5th generation programming languages. Can you name one? Prolog. Thank you. You've been studying Prolog. You've been studying Prolog. Does it code itself? I wish. This goes back to a very, very ancient time, even before the software crisis was recognized. Look at this from '59. One of the design goals of blah, blah, was to be readable and understandable to non-programmers, such as managers. Oh. Yes, COBOL. Quit saying punch cards every single time. There are no punch cards in the entire speech. Okay. Okay, this is an idea that comes back again and again. You don't need to write code. You can just assemble little boxes with little arrows, I don't know, rules engines. You can just drag and drop stuff on a palette, Visual Basic. You can compile your design, and it will just run UML, UML2. The first one was a little more down to earth. And it didn't work. The reason it didn't work was that, Ted Brooks knew 30 years ago, he wrote that in the mythical Man months. Most complexity in software is not accidental complexity. It's not complexity in the solution. It's complexity in the problem. Okay? It's essential complexity, which means that you cannot remove it. If you remove the complexity, you remove the software. So that's why this attempt failed, and they will probably try again and keep failing. So they tried something else instead. Some people said, okay, we cannot make software less complex. Maybe we can make people less fallible. We can make less mistakes, which sounds strange, but it's not that crazy also. Sorry. Because, for example, theoretical physics doesn't make many mistakes. It's equations. So, because it's math, it's mathematics. It's quite a sound set of tools that we can use to double-check the stuff that we come up with, and so we can make less mistakes. And so they said, why don't we apply math to software? We can prove that our software works. And they call these formal methods. These have been in fashion, at least in theory, for quite some time. A few years ago, I still met people who said that formal methods were the way out of the software crisis. And I was like, okay, if they are so good, how come that nobody's using them? And they said, usually, because they are expensive. It's quite expensive to do all that math. It requires very specialized people and a lot of time. And the stuff that you do is not important enough. It's not worth it. What are you doing for a living? Which domain are you working?
Ruby now, since August.
Yeah, but what are...
Music.
Music? Oh, okay. It's not worth it. Sorry.
Productivity.
Come on, productivity. Who cares about it? It's pretty much like porn. So at one point I had to ask every time, okay, what's important enough then? And sooner or later, people came down to aerospace. They said, NASA does formal methods because it's life critical. There are plenty of money at stake, and so they have to do math. So I went around on the internet and I checked how NASA actually makes software. And there are so many wonderful stories. I wish I had the entire day. I had to select one. This is it. Do you remember the Polar Lander in 2000? Who does? Some people do, okay? Those who don't, you don't remember it because it was a failure, actually. It was a probe descending on the Martian surface, and when it was 40 meters high, they lost the signal. And they waited for the signal to come back for minutes and eventually days, but it never came back. So they had the committee try to look into the incident and understand what had happened. And here is what happened, actually. They found out that because of a software bug, the probe was descending to the Martian surface. It was 50 meters and then 40. At 40 meters, they started the maneuver to open the legs to land. And when it opened the legs, it caused turbulence, so it started vibrating. And the onboard software thought, hey, we are vibrating, so we landed. And it turned off the rockets. So, so the probe, it was $165 million falling like a brick from 40 meters high and crashing on the frozen surface of the Martian North Pole. Serious. It was because of a missing conditional in the code. It lacked an if, okay? And they went in and looked at how could this happen? And they came up with a wonderful explanation. They said, well, Lockheed Martin, which was developing the software, was under pressure because of a deadline, so people were doing too much overtime. They were kind of stressed out, so at one point, they didn't test the software enough because they were assuming that if they did enough math, then they didn't need the tests. And, well, it didn't work. So apparently, you cannot replace testing, not even if you do a boatload of mathematics instead, and modeling. And this is why we couldn't eliminate human errors, not because it's expensive, because it didn't work. So there was a third attempt. We cannot make code less complicated. We cannot make humans less fallible. Maybe we can build a system that kind of evens out these problems and it smooths out these wrinkles and finally produces software like an industry. We can try to make projects look repeatable. There is project variability. My software project is different from your software project. And my software project tomorrow is different from my software project today. And they said, maybe we can iron this out. Because, again, other disciplines did that. Just a few years ago, there were people, even today actually, suggesting, let's do industrial engineering. Let's do it like other industries. For example, there was an initiative called Software Factories. Some people are still into that. It was sponsored by Microsoft, among others, that said, down with craftsmanship. We cannot afford that kind of amateurishness. We need to be like the big boys and be an industry, like an assembly chain. In other words, it's the notion that I heard so many times. Why aren't you like civil engineers? They build bridges. Does one bridge in 4 crash down spectacularly? No. Why can't you? Sorry? Well, even with software, people kind of die if you get it if you screw up real bad, you can kind of kill somebody. I never managed to do that, but God, I tried. Same thing with mechanical engineers. They design, I don't know, an engine. Do 3 engines in 4 come late over budget? No. So why can't you do that? Interesting. You seem to be quite an opinionated bunch, huh? Again. Do you want the mic? Fair enough. I was trying to involve you. You're not supposed to answer. I went around and I asked friends, how does civil engineering look like? What is it like to actually design buildings? And I found out that most civil engineers come up with the same explanation. They will tell you that there are basically 2 types of projects, or at least 2 extremes, and all the tones of gray in between. On one side, the repeatable projects. Like, for example, you design an IKEA shop. You don't expect big surprises. I mean, it's been done before so many times. It's basically kind of the same design, maybe tweaked. You do it again. It kind of works. That's repeatable. Design once, build multiple times, basically. And then there are the unique projects. as an example of a unique project far out there, here is one, Falling Water, by Frank Lloyd Wright, 1935. It's a beautiful example of a unique project. It's basically a modern monument. And, well, how did it go? It was supposed to cost 4,400, sorry, I don't know how much the dollar was worth in 1935. I think it was $40,000. It costed 4 times as much. As they were building it, they started having problems. You cannot really see them, but there are beams under the balcony there. Frank Lloyd Wright was offended by it. He said, "How dare you change my design by adding beams?" Well, the issue was that the balcony was basically sinking even before the house was finished. And then when they did finish it, it was so, the static qualities of the house were so bad that nobody could ever live in there. It was raining inside. It crumpled down, basically, and they rebuilt it in the 90s because it was a national monument for like $12 million. It didn't really go that well. And, I mean, sorry? Okay, that's a very good local example. La Sagrada Familia. Do you guys think you will finish the thing? I mean, ever. So, it's like the end of the world for Jehovah's Witnesses. Every time it comes by, you set it 10 years in the future. This is a sentence from the Scandinavian School of Architecture. If you do something good, if you do something unique, it's going to rain inside. It's a joke, but it's a telling joke. It's wonderful. Huh? All these issues stem out from one fundamental misunderstanding. I heard this again and again. I don't think that you share this misunderstanding, but just to make it clear. In civil engineering, there are 2 stages, a stage of project and a stage of build. And the project is the creative part, and the build is the mechanical part. So the build is made by builders, and you can make a project once and build multiple times, for example. Which stages are parallel these stages when it comes to software? The traditional view. What did they tell you? I don't know if you did university or if you have a formal training in software engineering. What did they tell you? Well, you can answer now. Okay, I will take one because it fits my presentation. There is a stage that parallels the project that is design. It's done by software architects. And then the humble coders come in and implement. Okay? So this is the basis for all the talk about industrial engineering in software. Now look at this. This is a blueprint. It's quite detailed. Very detailed. They can get much more detailed than this today because they use software to design houses. Now imagine a huge Japanese robot that takes this design and builds the house. Okay? Big-ass Japanese robot. Okay? It could be done. Okay, you have to build a really big robot. Let's see what happens in mechanical engineering. This is quite detailed. CAD/CAM. You can actually build it with a machine. You can build all the pieces and also assemble all the pieces automatically. You don't need humans. You barely need the human intelligence. Not really. But That's the assumption, that you barely need human intelligence to assemble. You just need the human intelligence to design. What's the software equivalent of these blueprints? It's the source code. Is it so natural for you? Because, I mean, some people took 30 years to understand that. The two stages, project and build, they are not equivalent to design and implementation. They are equivalent to development up to source code, which is the design, and compilation or build. We have the Japanese robot. It counts free. Okay? Compilation is free. It's so damn fast and cheap that we don't even notice it's there. Because the Japanese robot, the compiler or build system or whatever, will do it for us. And notice that the economics of this are completely different. Because when you build a house, the project is so cheap. Falling Water, they spent like 1/20 of that money to hire Frank Lloyd Wright, the biggest superstar architect of the time. In the case of software, compilation is free. You spend everything for the development for the programmer, like me or you, and we're not Frank Lloyd Wright by any means. So that's the main problem and the main reason why this approach failed. If you have 100 developers, you don't have 100 builders in a room. You have 100 architects in a room. And what happens when you put 100 architects in a room? In the 80s, we had all these methodologies, okay? Here are a few. A rational unified process, rational MyS. Prince 2. It sounds like bedtime stories, and it is. DSDM, this sounds nice and kinky, but actually it's only the masochism part that is there. They all thought that making software was like designing and building a house, not just designing a house. And they all failed because of that. They thought that making software can be defined as a process. It's a defined process, so I tell you exactly what to do. The project manager will fill in this form and pass it on to the, I don't know, who will in turn fill in this other document and pass it on to this other guy who will write a line of code. And it didn't work. Because it ignored the fact that projects are context dependent. Because context is everything. Same project, same people, even same delivery, they will deliver differently if you let them do the same thing twice. Context in software is finicky. So they failed. And this idea of eliminating project variability didn't work. So in the end, let's see what software engineering did. They couldn't eliminate internal complexity. They couldn't eliminate human error. They couldn't eliminate project variability. So we are kind of out of luck after 50 years. So what can we do? Like 10 years ago, we found an alternative strategy. We said, okay, we cannot eliminate this stuff. We cannot just deal with them. We cannot do away with them. We can cope with them. We can kind of embrace it. And how can we do that? By admitting that software is not a defined process. You cannot just define rules and stick to the rules. It's more like a trial and error process. It's empirical. So software engineering isn't. There is no such thing. It's just a failed concept. It never really worked. It's wishful thinking. What does Agile say? It says a lot of stuff, but if you forget about the manifesto and all of the debates, basically it's just three things. Agile says, basically, first, look around. look at where you are, look at the situation, and check the problems that you have. Like, for example, we noticed that when we deploy on Fridays, we tend to spend the weekend in the office. Problem. No kidding. Second, make a hypothesis. Like, maybe we can do meetings on Friday, so the boss will be happy, and we can deploy on Thursday instead. So if something unexpected happens, we have the time to fix it. And then you try it out. You make an experiment for one iteration, a couple of weeks. You try, and you see what happens. Oh, well, it didn't really work. We ended up staying in the office anyway. Okay, forget it. So you observe, you make a hypothesis, you make an experiment, you check it out. And what does the Ruby community do? You notice a problem. That's what you guys do. For example, yeah, that. You've been quoted. Okay. I meant you notice a problem, but apparently, okay. Now let's make a less loaded example. For example, you think, wow, mapping objects to relational databases, it sucks. I mean, I was in the Hibernate team. I know it really sucks. And it's a hairy problem. So you scratch that itch somehow. Like, for example, hey, maybe we can take the active record pattern and push it to the extreme consequences. Maybe, wait a minute, do we need a relational database? Maybe we can do away with something else instead. Or, I don't know, maybe we can just make a small DSL, and this DSL will generate SQL. And then you try it out, and you see whether it sticks. You put everything in the arena, and you see what survives. Simple as that. You notice a problem, you try out something, you see what sticks. Notice a parallel. Observation, hypothesis, experiment, which is actually nothing new. It's the scientific method. It's been there since the 18th century, at least. Software engineering has nothing scientific. It's completely unscientific. This is science. You formulate hypotheses, then you validate or invalidate the hypothesis. This is the parallel. For me, my 2 cents, this notion that there is this Darwinian selection of ideas, and people come up with crazy ideas, and no idea is too crazy. You just try them out. And you don't spend time discussing forever, like the Java community does, for example. You just try out stuff. This idea of throwing spaghetti at the wall, and if it sticks, then it's cooked. This very, very pragmatic approach. Okay? This, for me, this is why I'm into Agile, and this is why I'm into the Ruby community. It's as simple as that. This is why I'm into Agile. This is why I'm in the Ruby community. Thank you.
Thank you very much.
No way. But thank you.
So I guess there should be many questions.
Oh.
Yeah, of course.
Thank you. Bye. Josh. Hey.
I just want to say first off, I love you. And I want to know how you became so awesome over time.
Thank you. I was at an agile conference in Barcelona last week, and I complained against all the hugging that was going on. I said, come on, guys, we're here to make software. Quit hugging each other. It's kind of disgusting. I'm a consultant. To me, hugging means something. It's foreplay. When I hug a customer. But I will hug you later. I will. Yes.
I agree, concur. It's a good talk. Have you ever seen Glenn Vanderberg's talk on?
No.
It's a very similar concept. You should talk to him. The two of you would have much to talk about. Basically,
okay, I heard about it. We'll
yeah.
sort it out.
Yeah.
Thank you.
Okay. Thanks.